Hello everybody. Welcome back to Web3 Protocol Africa. My name remains Emmanuel Fedora, and I'm a blockchain enthusiast and also a protocol engineer in this space. Um, so today I'll just basically be sharing my progress with the EVM that I started about some weeks ago, right? Yeah. So I'll be sharing my progress with that, on that rather. Yeah. Um, so I did a video sometime talking about the EVM, how the EVM is a virtual machine, I basically explained what a virtual machine is, how a virtual machine is basically like a software that is supposed to be an emulation of an actual computer, right? Yeah, so I did that, and I gave an instance. I gave an example. I said that we have two types of virtual machines. We have the system virtual machine and we have the process virtual machine. So the process virtual machine is where the EVM falls into, because the process virtual machine is basically a kind of virtual machine that is boxed or is contained inside of a process. And I went further to explain what a process is, how a process is simply a program in execution, or an instance of an executing program, right? Yeah, so having said that, yeah, I'll just be sharing my progress. So let me move into my folder. So, yes. So today I'll just be showing like a few pieces of code. So I'll walk you through some of the logics I use for the implementation of my EVM, right? Yeah. So first of all, I want to talk about the stack. Yes, we can talk about the EVM without talking about the stack, because I think it's more like, for me, it's more like let's see, it's one of the main data structures of the EVM, right? Yeah. So first off, the stack is it's according to the EVM codes. The stack is basically a list of 32 bytes elements, right? So it's basically a list of 32 bytes elements. So in a list we have the list contains 32 bytes elements, right? Yeah. So here, so the stack basically has different functions. We have the push function, which is used to push an element onto the stack. Of course, we know that the stack uses the LIFO, yeah, the last in first out, kind of like data structure. Yeah, last in first out. So anything you place in to the stack last is going to be the first to come out. So the stack has the push function. It has a push function. It has the pop function, which is used to like pop out a data from the stack. We have the pick function. We have the swap function, and we have the duplicate function. While all these are just basically helper functions that are used to, this is used to get the size of basically the length of our stack, and this is used to get an item at an index position, and this is used to basically print what is on the stack. Yes, just print it to a string, that kind of thing. Yeah. So here we have the push function. So how I defined my structure of the stack data structure, I basically used because it's a list of 32 bytes elements. So I use this um, data type, this uint 256.int data type, so it could hold like 32 bytes elements, right? So here that happens. Then here I this is a factory function. A factory function is basically used to initialize a certain type of data type. Yeah, a certain type of data type. So that is what a factory function does. So here I'm returning a pointer, a pointer to my stack element, right? Yeah. So here we have my push function. Like I said, the push function is used to push a value onto the stack. So before I do that, I have to like confirm the size of the stack to make sure that the size of the stack is not more than the maximum amount of elements we could have in the stack, which is I think around 1024 elements for the stack. Yeah, right. So whenever it's more than that, we have to come here and we return an error message, which is stack overflow. Yeah, stack overflow. So then if it's no more than that, we basically continue and push that element onto the stack. So here for the pop, we come and we also do a checking to make sure that the stack is not empty, right? So here we're checking the stack is not empty. If the stack is actually empty, we return nil, because we're supposed to return the value from the stack and also an error. So return nil in place of that value, and also return stack underflow error. But if that's not the case, we actually move on and all of that. So peak, we have the peak, we have the swap, and we have the duplicate. Yes. So having said that, let's press further. I think I've talked about the stack. Let me just run the code. Let's see how it works. So let's do that. So I'll just build the code. Go build. So it's going to give me an executable, which is this, the Go EVM. Go build does that. It's going to give you an executable file. So if we should run this, I should run the Go EVM. So like I've told you in one of my videos, I said how I'm going to be implementing my EVM. I'm going to make it interactive, whereby there's this way it acts, whereby it's REPL, which is read, evaluate, print, and loop, right? So it's more like we have a prompt that is waiting to take input from the user, right? Yeah. So here it says type help for available commands. So if I should type help, yeah, so it prints out what I put in there for it to print out. So it says run. So if we should type in run, it requires a bytecode. So where do we get bytecode? So there's this website called EVM.codes, right? So from here we could actually get a bytecode. Yeah, so I'll come to playground. Now pick this bytecode. Yeah, pick this bytecode. I'll place it here. So you see what happens. It says running bytecode. It appends the 0x to tell you that it's an hexadecimal, that the bytecode we are passing is in hexadecimal format. So it places 0x there. So it says execution successful, and the result is all these figures. Then the stack is actually empty. So we're still going to analyze the bytecode. Yeah, we're still going to analyze the bytecode. So the memory, we have the data 42 in there, and the gas used is 18. So this same bytecode, if I should come to this EVM.code/playgrounds website and I run this bytecode, we're just trying to see if we get the exact thing output as we got on my own implementation of the EVM. So let's do that. So I've run the code already. I've run the bytecode. So let's walk through each step in execution. So if I should hit this button now, it says push 1, and we know that, like I said, the bytecode contains opcodes and contains data. So here, push 1 is going to represent 60. 60 is the opcode for push 1. Right? So if I should hit here, so it's going to push 42 onto the stack. So you see what happens? It pushes 42 here onto the stack. Right? So push 1, 0, 0. So it's going to push 0 onto the stack. So I did that. So at that point, the data contained in memory is 0. So if we do mstore means to store a value in the memory, rather. So I'll talk about the memory in our next video. So it does that, right? So we store the data that we had in our stack. We store it, we push it onto memory with mstore, right? So we have push 1 again, push 20, and mind you, this is not 20 decimal. This is actually 16 in hexadecimal, right? Sorry, this is 32 in hexadecimal. I'm sorry for that. This is 32 in hexadecimal. If you convert it to hexadecimal, it's 32. So place 20, which is, sorry, I'll just say 20 rather instead of 20, because it's not 20. This is hexadecimal. 20 rather, it places 20 on the stack, right? So we have push 1 0, so it pushes 0 onto the stack. Then we return. At this point, we've not moved anything to the memory, so it is what is in memory that is going to be returned. So if you call return, it's going to return what is in memory. And if you look at our own execution here, it did the same thing, the exact same thing as expected. That is what it did. So I have this part of my program where if I type debug and I pass in that same bytecode, it's going to like do the same thing that we had here. Right, it's going to do like the same thing, like a walkthrough. It's going to walk you through what we have here. So if I should hit enter, so it said debugging this bytecode, the program count, which PC is program count, and the opcode is push 1. So the program count at the the opcode at the program count of 0 is push 1, which is 60, right? So at that point the stack is empty. Sorry, let me reset this. Let me quit. And let me reset my stack so that everything is back to it. So it says execution context reset. So I'll be sharing more of this, how I implemented all of this in a subsequent video. So let me just do that debug again. Debug, and I put in the bytecode, right? So it says debugging bytecode. So the first opcode is push 1. Initially our stack is going to be empty because here we've not pushed anything onto the stack, and the memory is also going to be empty. So I'm going to continue. It says press enter to continue or Q to quit. So I press enter. So at this point it has already pushed 42 to the stack, which is from here. It says push 1 42. So we've pushed 42 to the stack. Then we move on. We push 1, we push 0 0 to the stack as well. So the stack contains 2 values now. So if I continue, now we're at the opcode mstore. So if I hit enter now, we store the value from the stack, we store the data from the stack into memory. So we store 42 into memory, right? Yes, that's what mstore does. So the next opcode is push 1. And what are we pushing? We're pushing 20. Yeah, so 20 is now on the stack. As you can see here, 20 is now on the stack. 20 is now on the stack. So let's press further. So if I hit enter, where's my bytecode? Remember our bytecode is here. This is what we're debugging. We're debugging this bytecode. If I hit enter, it's going to push 0 0 onto the stack. Yeah, so it does that. 0x0 pushes it onto the stack. So if I should hit enter, remember our last opcode here is F3, which is the opcode for return. So it's going to return everything. It's going to return the value from the memory to us. So that is what it does. So it says execution stopped. Reason either stop or return, which in our case is return. So the return data is actually 42, and the final memory is actually 42. So as we can see, and the gas used is 18, right? So this is literally the same thing we have here. We have the gas here is 18. Don't mind the 21,000. That is the already set figure. So that is that. So it's basically the same thing. It's basically, so that this is my implementation of the EVM. It's still work in progress because I'm here to implement storage. I'm here to implement transient storage. I'm here to implement that. So, and I hope I'm able to do more than just stopping at transient storage and storage. I hope to make it like, I hope to add more functionalities basically. Yeah. So thank you for joining. Thank you for watching. My name remains Emmanuel Ifediora, and this is Web3 Protocol Africa. I'll be dropping our handles. I'll be dropping our handles in the description section. Yeah, thank you.